Hi everyone, in this video we shall take a look at the topic of alkanes. So in the previous lesson we discussed what homologous series were, and the alkanes are just one of those homologous series that we are going to study. So what exactly are we going to look at in this lesson? We're going to look at some of the trends in physical properties pertaining to alkanes when the size of the molecules increases. In particular, there are melting and boiling points, viscosity, flammability. At the same time, we are going to study their general formula and know how to name and draw the first few members of our alkanes. We are also going to learn the chemical reactions involving alkanes, namely combustion and substitution. Where do our alkanes come from? They come from petroleum and natural gas. These are our fossil fuels. Petroleum is, in other words, known as your crude oil. And when you do fractional distillation of crude oil, you're separating crude oil into the various fractions, each containing a mixture of different alkanes. Natural gas is mainly made up of methane with the formula CH4. Alkanes are hydrocarbons that contain only single covalent bonds between carbon-carbon atoms, so single bonds only. We learned about the naming, so alkanes always end with the ane suffix. The first member of our alkanes family is methane, and over here we see their dot and cross diagram and structural formula. Always remember, because carbon has 4 valence electrons, it will need to form 4 covalent bonds. What's the definition of alkanes? Alkanes refers to the homologous series of saturated hydrocarbons. This is just general formula, where N represents the number of carbon atoms in the molecule. A recap, what does saturated mean? Saturated molecules have only single bonds between carbon atoms, whereas the term hydrocarbon refers to molecules containing only carbon and hydrogen atoms. So all your alkanes, we can describe them as being saturated hydrocarbons. Let's spend a few minutes to fill in this table. On the left, we want the molecular formula, the ratio of carbon to hydrogen. Here we have the written structural formula and the full structural formula. The written structural formula is a condensed version of the structural formula where we read it from left to right. What do I mean? Going from left to right, we have a CH3, CH2, CH3. Okay, so CH3, CH2, CH3. We break it up for every single carbon atom like that, right from left to right. Spend a few minutes to try this and then we'll discuss the answers. Here are the answers. Have a look and check if you have gotten the correct answers. Right now it's time for checkpoint. Again, spend a few minutes to attempt the questions and then we'll go through. For the first question, we'll require the general formula of an alkane, CnH2n plus 2. So when an alkane has 12 carbon atoms, we are saying that n equals to 12. So this gives us C12H26. Okay, so the relative molecular mass, or the MR, will be equal to 12 times AR of carbon plus 26 times 1. That gives us 170. Remember, MR has no units. Question 2. An alkane containing 4 carbon atoms. We have 4 carbon. We draw this first. And remember, each carbon has 4 bonds. So I'm going to make sure that there are 4 lines coming out of each carbon. Next, we are going to fill in the remaining hydrogen. So the full structural formula requires you to show all the bonds in the molecule. Question 3. Calculate the number of moles in 5 grams of ethane. Ethane is C2H6. So your number of moles equals to the mass over MR. We have 0.16666 moles, which we round to 3SF for our final answer, 0.167 mole. In the next section, we'll look at the physical properties of alkanes. Alkanes are covalent substances, and therefore they exhibit the typical properties of a covalent substance, meaning they are insoluble in water and they have low melting and boiling points. I'll just like you to cancel this because we'll talk about burning in the next section. Okay, so for now, just know these 2 points. Our alkanes family show a trend as the molecular size increases. So when the molecular size increases, we observe that the boiling point as well as the melting point will increase. This is due to the increase in strength of intermolecular forces of attraction. As the strength of intermolecular forces of attraction increases, the density will increase because the molecules attract one another more strongly and they come closer together. And this will mean a greater number of particles per unit volume. Viscosity is also related to the strength of intermolecular forces of attraction. When the molecules attract one another more strongly, they become more viscous as they resist the tendency to flow. Going down the series, as the number of carbon atoms increase, the flammability would decrease. So this is the only trend that is opposite from molecular size. Why is that so? It's because when we have more carbon, we need more oxygen for complete combustion, and therefore, when molecules become bigger, they become less flammable. If you remember when we studied group 7 elements, you will recall that going down group 7, the boiling point and melting point also increases, and the reason is the same as what we discussed over here. So as the molecular size increases, intermolecular forces of attraction become stronger. What I've just discussed with you are detailed in sections 3.2, 3.3, and 3.4. Okay, so you can go ahead and read these for yourself. Let's illustrate why increasing the number of carbon atoms make it less flammable. So if you recall the equation for combustion, when a hydrocarbon burns in oxygen, you get carbon dioxide and water. And I think straight away you'll notice that this equation is not balanced. Okay, it should be like that. So I'm going to demonstrate one example and you'll try the other. Okay, so let's write for methane. When we refer to complete combustion, the products are carbon dioxide and water. The first step is to balance carbon, then balance hydrogen, then balance oxygen. Carbon is already balanced. I'll put a 2 here. And then we count. I shall need a 2 over this side. Can you give it a try for ethane? The formula for ethane is C2H6. Same thing, we balance carbon first. So I'll put a 2 over here. Balance hydrogen. Now for oxygen, how many oxygen atoms do we have on the right hand side? We have 4 plus 3, we have 7. How do I get 7 oxygen atoms here? It means I will need 3.5 oxygen molecules to balance the equation. But remember, you cannot have decimal or fractions in your final answer. So you multiply by 2 throughout. Okay, what I want you to compare is the mole ratio of the hydrocarbon and oxygen. For every 1 molecule of methane to burn, we need 2 molecules of oxygen. This is 2:7, meaning for every 1 molecule of ethane to burn, we need 3.5 oxygen molecule. And for this, we need 5 oxygen molecules. So as you can see, the larger the hydrocarbon, the more carbon atoms there are, the harder it is for complete combustion to happen because there is a greater amount of oxygen needed to have complete combustion. Okay, and when you do not have complete combustion, you tend to produce products like carbon monoxide or carbon. This will lead to a smokier flame due to the production of carbon or soot. So there is a correlation between the flammability and the percentage by mass of carbon in the molecule. So with more carbon atoms in the hydrocarbon, the percentage by mass of carbon increases. Let's spend some time for this checkpoint. Pause the video, give that a try, and we'll discuss. Question 1, answer is D. Homologous series have the same general formula, same functional group, and they show a trend in physical properties as the number of carbon atoms increase. We always go back to these 3 points. Question 2. When we have more number of carbons, what happens to the boiling point? So larger molecule, boiling point increases. Okay, so we're going to look at a trend that looks more like graph A. Why is it not B? Is because here the first part is horizontal and it doesn't accurately show the increase. Okay, so it should always be increasing. So A would be a better answer. Next up, we'll look at the chemical reactions involving alkanes. The first chemical reaction is combustion. There are 2 types of combustion that can happen. Either you have complete combustion or incomplete combustion. Note the difference between complete and incomplete combustion. When you have an excess of oxygen, complete. When you have a limited or insufficient amount of oxygen, you have incomplete combustion. In complete combustion, the products are carbon dioxide and water. In incomplete combustion, the products are carbon monoxide and water. Sometimes, in addition to carbon monoxide, you get carbon as well, or what we call soot. The table below shows the differences in the equation when you write for complete and incomplete combustion. Because they burn readily and they release energy when they are burnt, exothermic reaction, alkanes are commonly used as fuels. This part will be new to you. Alkanes undergo one chemical reaction which is called substitution. What is substitution? Is when you take out one hydrogen atom from the hydrocarbon, you put in something that is different. Okay? When does this happen? It happens when you have your alkane. Firstly, you need that. You need a halogen as well. Halogen referring to your group 7 elements, and typically chlorine, bromine are used. And the condition for the reaction is ultraviolet light. Let's look at the structural equation, which will make a bit more sense. Okay, so this is methane. This is chlorine. Remember, chlorine is diatomic. So with UV light, what will happen is this bond will break. Okay, and you will release chlorine atoms. This chlorine atom has 7 valence electrons. Correct? And you'll want to gain 1 more to have a fully filled valence shell. So what happens is you will go and look for its friend here. Okay, you will take away the hydrogen like that and form HCl. Okay, so chlorine snatches hydrogen away. Then the other free chlorine atom will connect here, which is what we see on the right. How do we name this molecule over here? So it has 1 carbon, right? And 1 carbon, typically we call it a methane. Okay, with this chlorine, we add an extra front part of the name. We call it chloromethane. The other product that is formed is called hydrogen chloride. Only when it's dissolved in water, then we call it hydrochloric acid. Otherwise, we just call it hydrogen chloride. So we have seen the first step in this reaction is it is possible that we can substitute until all the hydrogens have been fully replaced, provided we have an excess of chlorine gas that is supplied. Now let's take a look at the checkpoint. Spend some time to look at the questions and then we'll discuss. Question 1, we have ethane. Ethane has this structure, right? So when it undergoes combustion, the bonds here will all break. So carbon-carbon bonds will break. It does occur. Need to break this. Then formation of carbon-oxygen bond is true because when you burn, it forms carbon dioxide as the product. So you form bonds between carbon and oxygen. Production of soot does not occur because this is complete combustion. Soot only forms when there is incomplete combustion. And finally, water is one of the products as well. Question 2, which show all the possible combustion products, and this one they never specify whether it's complete or incomplete, so we'll include everything. So you could have soot, you could have carbon monoxide, you could have carbon dioxide, you could have water. Okay, all are possible. Question 3, which substance reacts with methane? So methane reaction, there are two kinds. You have combustion, you have substitution. For substitution, it involves halogen, like chlorine or bromine, and the presence of UV light. Okay, so you have to choose from the list, chlorine will be the answer. Okay, got that? Okay, one more question I'd like you all to think about. If I have ethane and I were to add bromine, I give it UV light. Can you tell me or draw for me what products will be formed? You may want to pause and think. So this is an alkane. Alkane undergoes substitution, meaning I'm going to swap their places. Can you guess what is the name for this? Okay, if you have guessed bromo, ethane, you are right. So ethane, because there are two carbons and it's an alkane, all single bonds. Bromo, like chloro, tells us that there is a bromine atom attached. Okay, then here, like hydrogen chloride, we call it hydrogen bromide. Okay, so that's all for substitution. Know what is the condition and now to draw and name the products for me. So that's all for today's lesson. See you next time.